So we are looking at NS5-22 advanced arrays. This is a method of understanding multiplication using larger numbers. So this is sort of the start of it. So what multiplication statement do you see in each picture? So here we see a few different arrays. And in the first array, we have 2 rows. Pen doesn't seem to be working here. There we go. 1, 2 rows, and there are 5 in each row. So we have 2 groups of 5. Here we have 3 rows, and then there are also 3 in each row going across. So that's 3 times 3. So our first number always represents the number of rows. 5 rows with 3 in each, so 5 times 3. So we can use that to represent larger numbers. So what multiplication statement do you see for each part of the diagram? So we have a part that's here in white, and then we have another part that's represented in gray. So in the part that is represented in white, we have 3 rows, and there are 10 in each row going this way. So that's represented by 3 times 10. And then we have those same 3 rows, but this time there are 3 in each row, and that's represented by 3 times 3. So for the whole diagram, we can actually view it as 3 rows of 13, because there are 10 here and 3 over here, and 10 plus 3 is 13. So we have 3 times 13, or 3 groups of 13, or 3 rows with 13 in each. And it says, how can we get 3 times 13 from 3 times 10 and 3 times 3? Well, if you remember back when we were doing place value, we learned how to take numbers and pull them apart. And we can see the number 10 and the number 3. And when we put 10 and 3 together, we get 13. And we have 3 times 13 from that. So think about it. 3 times 10 plus 3 times 3 equals 3 times 13. Because here we have 10. Here we have our 3. Make a model to show that 4 times 25 is the same as 4 times 20 plus 4 times 5. So here we have 25. We have our 2 groups of 10, and we know 2 groups of 10 is 20, and then we have our 5 ones. So 20 plus 5 equals 25. So now we see a model of that. We have 4 rows, so this is step 2, 4 rows with 25 in each row. So from here all the way across, we have 25. So that is 4 times 25. But when we break it apart, so step 3 is to break the array into 2 separate arrays. So now we have same 4 rows, but we're only looking at 20, and the same 4 rows again, but we're only looking at the 5. And we know what 4 times 20 is, and we know what 4 times 5 is. So it makes it easier for us to calculate that in our head when we can break the number apart into 2 different multiplication statements. So here's an example of that. So this is called the distributive property. So down at the bottom, there's a little statement here. It says, this shows the distributive property of multiplication. So they've shown how 5 times 5 can be written in multiple ways. And in fact, they've taken the array of 5 times 5, and they've broken it into 2 different arrays. So that we have 3 times 5, and then 2 times 5. So they've now shown this as a separate array, which is the same thing as 3 times 2 and 3 times 5, okay? So looking at this, 10 times 2 plus 4 times 2 equals, it says what would happen if we did the operations in the order they appeared? Meaning we did 10 times 2, which is 20, Then we added the 4, which is 24. Then we multiplied by 2. Well, 2 4s are 8 and 2 2s are 4. It would equal 48. Is that the right answer? 10 times 2 is 20. 4 times 2 is 8. It's not the right answer. It's 28. So we cannot, when we're doing questions like this, we need to put these brackets in that you see up here on the screen so that we know to do our multiplication first inside the brackets, and then we add afterwards. So in the distributive method, we need to make sure that when we're pulling it apart, we do those multiplication pieces and then we put them back together at the end. So you're going to work now on NS5-22 in your booklets.